Hello there and welcome to lab number 2 in our series of light and optics experiments. The title of this lab is Semiconductor Laser Diode Basics. This series of light and optics experiments is using two different types of light sources, LED flashlight and a red laser diode. A red laser diode is a type of a laser source that is going to be used in most of the experiments, and this lab too is intended to introduce this type of a laser source. First, I'm going to ask you is to read a very comprehensive theory introduction into lasers and the laser applications, followed by the theory behind operation of a laser diode. You will learn about the construction of a laser diode and the way how it is producing a directional and a coherent beam. And then in the practical part of this lab, we are going to look at our laser diode module. We are going to take it apart. We are going to look at the construction fixture. We are going to look at the focusing optics that's being used to collimate a very diverging beam. That's an important characteristic of laser diodes. And finally, we are going to touch upon the subject of the laser safety. We will see that our laser diode is a class 3A type of a laser for which you have to implement certain laser safety measures to protect your eyes against any kind of possible injury. The equipment that is going to be used in this lab consists of a red laser diode module. We have here fixture into which the red laser diode is placed. We have a cable and finally adapter. This adapter is to be plugged into AC power and it's going to convert AC voltage into 3 volts DC that is used to power our red laser diode. And then finally we also have here tweezers. You may use these tweezers if you decide to take apart red laser diode and look into the focusing optics that's part of this fixture. So this front side of the fixture is where the focusing optics is positioned, that's being used to collimate the beam of red laser diode. What we have here is a red laser diode module that is being used as a laser source in the labs in this series of experiments. Here in front we have the laser diode module in the fixture, we have a cable, and then here we have adapter that converts AC voltage from the power grid into the DC 3 volts that will be used to power our laser diode module. So we are going to familiarize ourselves with this red laser diode module that is being used in this series of experiments. First, you can see that a laser diode module inside of this fixture is connected to this jack, so we can actually disconnect it here to remove the cable and the adapter. Again, as you can see, we are dealing with an adapter that converts AC voltage into the 3 volts DC that's being used to power our red laser diode. Throughout this lab you're going to learn that red laser diode is a type of laser that is being powered by an DC electrical current. So the current is being used to pump the energy into the active medium of this laser diode module. So let's start taking this whole fixture further apart. So what I did here is I pulled out a laser diode from this fixture. So this fixture, as you can see, its sole purpose is to keep the laser diode in a specific direction so that you can point it in a desirable direction during your experiments. So what you can see here is a laser diode fixture on the top. You can see 2 wires, one red for positive and then one blue for the negative polarity of the voltage, and then down on the bottom here is where we are connecting our cable jack and providing electricity. As you can see here, if I connect and then obviously if I connect this into the AC power grid, this laser diode will be producing light. What you can also observe here is that inside of this fixture there's a little bit of optics here, so there's certain lenses that are being placed here as a part of the focusing optics. We will learn a little later that the laser diode is producing an elliptical beam pattern, and you need to collimate that beam because it's a very divergent beam, meaning as you're moving away from the laser diode, the beam keeps expanding in diameter, and not only that it's expanding in diameter, also without the focusing optics it would have an elliptical cross section, which is not desirable in most of the experiments. So what we want to do is we want to put some sort of focusing optics here that are going to collimate the beam, meaning it's going to reduce the divergence of the laser diode beam as number 1, and then as number 2 it's also going to reduce the elliptical pattern and turn it more into a circular beam pattern. This diode fixture can further be taken apart, so if you twist it, you can take it apart and you can see what is inside. So you can see here that inside of this fixture there is a small spring load, and then further inside is going to be a small resistor that's being used to limit the current. We said that electric current is being used to power the laser diode, so inside we have a small resistor. Okay, now guys, you can see here I took the small focusing lens out of this fixture. So this small optical component, this lens was part of this fixture. It's been placed in front of the laser diode, and as already mentioned, this focusing lens is used to collimate the beam, to reduce the divergence, and also to reduce the elliptical shape and turn it more into a circular shape. So you can see how this focusing optics looks. And as I said, it goes inside of this fixture and serves the purpose of beam collimation. Now, what we also want to see is how does the beam of this red laser diode look without the focusing optics. So what I have here is just the laser diode. And as you can see here, I have removed the front fixture. Now, what's of interest for us is to see what kind of beam does this laser diode produce without the focusing optics. So what I have here is the front fixture removed, with the front fixture with the lens being removed, and we have just a red laser diode with a current limiting resistor connected to the cable jack. So what I'm going to do now is, here in the back, I'm going to connect the 3 volts DC coming out of the adapter, and let's see what kind of beam we are going to produce. So you can see the beam of this laser diode being very elliptical in shape, and you can see that the width of the beam is significantly being expanded as you're moving away from the screen. We're talking about a significant divergence of the laser beam coming out of the laser diode. That's one of the most important properties of laser diodes. So laser diodes are types of lasers that are, due to their structure, producing a very diverging beam that's of the elliptical shape. Let's now see what's going to happen with this laser beam when we put the focusing optics. So we're going to put back this front fixture with a small spring load and the focusing optics. Okay, so let me place the collimating lens inside the fixture, and then we are going to put the spring load. Finally, we are going to screw in the rest of the fixture with this front part. Screw it in, and here we have established our full laser diode with the focusing lens in the front. Let's now connect it to the jack, to the 3 volts DC. So here's the cable jack and 3 volts DC. And let's see how our laser beam looks now. You can see here now that our laser beam is a significantly much better collimated, and you can see that it's less of an elliptical shape. It has a certain divergence still, but much less than what we had without the focusing optics. And as I already mentioned, we also have this fixture that's being mounted to the laser diode so that we can better control the direction at which we are shooting the beam. The last and probably the most important thing in this lab to be mentioned and to be noticed is that this laser diode is about 5 milliwatts in power. So it's being powered by 3 volts DC, and it produces the laser beam that has a power of about 5 milliwatts max. And as such, this laser would be classified as a 3A, which means that this laser poses hazard for your eye if the laser beam is being shot directly into your eye. So you would want to avoid pointing in the direction of your face or your eyes with this laser. And what's also important to mention is it's not just direct exposure to the laser beam, but you also would want to be very careful about specular reflections. If we have a mirror here, as you can see here, the mirror would reflect the beam, and that beam is going to continue as a reflected beam, and that's going to have the same power as the power of the original beam. So you would want to be very careful about not being directly exposed to not only the direct beam coming out of this laser, but also to these specular reflections. Specular reflections will be covered in a different lab. We're talking about reflections off of the smooth surfaces that are not spreading the power of the beam, but keeping it directed in the same way as the incident laser beam. So again, be very careful. Apply all the instructions, all the safety rules that have been covered in lab titled Laser Safety. Again, we are dealing with a 3A laser. In certain instances, you would want to use laser safety goggles if you're running the risk of your eyes being directly exposed to the laser beam. As long as your eyes are not directly exposed to this laser beam, you're okay. But if you're going in the front of this laser to do any kind of alignment, or if you are running an experiment where specular reflections can be produced, then you would want to be careful. You would want to protect your eyes.